Hello everyone. Today we will walk through a Python script that identifies all subarrays within a given array whose elements sum up to a specific target value. So by the end of this session, you will understand how the code works, how to apply it to your own problems. So let's start by clearly defining our problem. Imagine you have an array of integers and target sum. Our goal is to find and print all contiguous subarrays within this array that add up to exactly to the target sum. Let's consider an example to make this concrete. Suppose our array is 10 minus 2, 10, 2, minus 2, minus 20, 10, and the target sum is minus 10. So we want to find out what are the subarrays within the array that sum up to minus 10. So as per this problem, the expected subarray should be these two are the things. So the subarrays that meet this criteria are given here. Okay, we will see how our script identifies these. So our approach involves calculating a cumulative sum as we traverse the array and using a hash map to keep track of these sums and their indices. This method allows us to efficiently identify subarrays that add up to the target sum without checking every possible subarray. So the main function is the find subarrays with target sum. So takes the array as input and the target sum. So it initializes necessary variables, traverses the array while updating the cumulative sum, and identify valid subarrays. Finally, we have an example, numerical example that is like a numerical example walkthrough to show how this function works. So here is the final code that involves the whole logic. So we will discuss step by step. So first one is this part of the code. So it is the initialization. So it is the beginning of our function, right? So we initialize three key components. First one is the sum map. That is a dictionary to store cumulative sums and their corresponding indices. And next one is the current sum. So a variable to keep track of the running total as we iterate through the array. Next one is the result variable. That is a list to store the tuples representing the start and end indices of the valid subarrays. So this part of the code is navigating or traversing the array. So we start traversing the array using a for loop. For each element, we add its value to the current sum, which keeps a running total of the elements we have seen so far. And the next phase of this code is the checking the target sum. So in the previous stage, we have acquired the cumulative sums, right, for every element. So in the checking phase, of the target sum, so that is once we updated the current sum, we check if it equals the target sum. If it does, that means the subarray from the start of the array up to the current index I sums to the target. We append this range as a tuple to our list. So that is 0 is the starting index and I is the end index of that subarray whose sum is equals to the target sum. So now next phase is it's another checking condition is using when should we use the hash map. So now what we do is we check if the current sum minus the target sum exists in our sum map. So if it does, it indicates that there is a subarray ending at the current index I which sums to the target. So we iterate through all starting indices stored in the sum map and append each valid subarray to the resulting list, right? So finally updating the hash map. So finally, what we do is we update our sum map with the current cumulative sum. The current sum is already a key in the dictionary. We append the current index to the list of indices. If not, we create a new entry with current sum as the key, and this we try to add I because it wasn't there, so we have to newly create that entry into this dictionary. So in order to, we have understood the code from the previous slide, right? Now we will walk through the code by considering a numerical example. Okay, so this slide basically shows how the above code works at every index. So suppose, for example, at index 0, the current sum is 10, right? So the array what we are considering as input is this, and the target sum is this. So we are applying the above code through this numerical example. So current sum is 10, right? When we are at 10, the current sum is 10, cumulative sum. So since it doesn't sum up to minus 10, and we have to uh, go through this one. So we have to create new entry, right? Because this doesn't satisfy and this doesn't satisfy. So this part of the code satisfies, right? So the you have to update sum map. That is 10 is the entry cumulative sum, and where is that corresponding index. And similarly, we have to navigate through index 1. So, and similarly for index 2. So if you apply the above code and just have a look at this numerical example walk through and using that above code, you will be able to understand it. Okay, so finally, this kind of walkthrough will give you how we need to like how the functionality of the code works. So finally, the time and space complexity. So the time complexity is often because single pass to the array, and the space complexity often because stores for the hash map.